This example takes the important mole concept and turns it around. Instead of converting from grams to moles, in this case we're going to convert from moles to grams. We know that there are 12.331 moles of NH3. The question is, how many grams is that? Now, whenever we do any conversion between grams and moles, we always have to start by looking at the periodic chart. Ammonia, NH3, has nitrogen and hydrogen in it. So let's look at those entries in the periodic chart. Why do we need to look at these entries? Well, remember what the ultimate goal is. We need to find a conversion relationship between grams and moles. We do that by figuring out the mass in AMU. The mass in AMU also tells us the number of grams it takes to make a mole. So we've got to figure out the mass of NH3 in AMUs. That's pretty easy. Below the nitrogen, there's a number of 14.0. This tells us the nitrogen has a mass of 14.0 AMUs. Therefore, ammonia is going to have 14.0 AMUs plus the mass due to the hydrogens. Hydrogen has a mass of 1.01 AMUs. There are 3 hydrogens in an ammonia molecule, so I've got to take that 1.01 and multiply by 3. When I work out the math, I get a mass of 17.0 AMUs. Calculator actually says 17.03, but I have to ignore the hundredths place because I'm dealing with addition, and in addition we have to look at precision. 14.0 only goes out to the tenths place, so my answer can only go out to the tenths place. So the mass of ammonia is 17.0 AMUs. Well, the mass in AMU also tells you how many grams it takes to make a mole. So the fact that NH3 has a mass of 17.0 AMUs also tells you it takes 17.0 grams of NH3 to make 1 mole of NH3. So that's our conversion relationship. 1 mole of NH3 is the same as 17.0 grams of NH3. Now we can do the conversion. We take the number we have, 12.331 moles of NH3, and we make it a fraction by putting it over 1. Then we multiply by 1, but the expression we use for 1 comes from the conversion relationship. I need to get rid of moles of NH3, so that has to cancel. So moles of NH3 goes on the bottom. I need grams to survive, so they go on the top. So my conversion is 12.331 moles of NH3 over 1 times 17.0 grams of NH3 over 1 mole of NH3. The moles cancel, and I'm left with 209.627 grams of NH3. Now that's way too precise, so we have to figure out significant figures here. 12.331 has 4 significant figures. 17.0 has 3. So my answer can have only 3. So I'm going to have to drop that 627. Problem is I'm dropping a 6, so I have to round up. So the answer is 210 grams of NH3. Now wait a minute. 210 has only 2 significant figures. That 0 isn't significant because it's at the end of the number, but it's not to the right of the decimal. So here's another situation where you have to use scientific notation in order to conserve significant figures. I need 3 significant figures. The only way that 0 can be significant is to be at the end of the number and to the right of the decimal. So I've got to get a decimal into this number. The only way to do that is to make scientific notation. So 210 is the same as 2.10 times 10 to the 2. Now I have 3 significant figures, and that's my answer.